Hey everyone, this is Mr. G here with just going to do a run through of the metric conversions practice that we were working on this week. Before we get started, I just wanted to tell you guys you don't need to memorize all of these prefixes. Um, you can use a table. I posted one on Google Classroom. If there's another one that makes more sense to you, that's fine. But we don't need to memorize these prefixes because they're given to us. But what I do want to make note of is that when you see these in front of one of our units, so say we had a kilometer or a centimeter or a milliliter or something like that, you can treat these letters almost like you would treat pi in geometry. It's just instead of equaling 3.14, it represents one of these 10 to the power of, in this case, 18 through negative 18. And there are a few other ones, but most of the time we only use a few of these anyway. So again, you don't need to memorize these prefixes. You'll always have access to a table if it were a test or something. But just get used to treating them like pi. It's a constant. We just represent it by a letter. So I'm looking at the first problem here, and it says 1 light year is the distance light travels in 1 year. This distance is equal to 9.461 times 10 to the 15 meters. After the Sun, the star nearest to Earth is Alpha Centauri, which is about 4.35 light years from Earth. Express this distance in A, megameters, and B, picometers. So I'm going to move over to my sheet of paper here because I don't have room on that worksheet to do it. And it's giving us a distance of light years, huge distance. But we need to convert this distance between Alpha Centauri and the Sun, which is about 4.35 light years. We need to get that in meters first before we can convert to megameters or picometers. So for 1A, I'm going to set up one of these tables. I know it kind of scares some of you, but it really does make life easier once you get used to using it. So the first distance I'm given is light years. So I'm going to put that in this first box. Now, I'm just writing LY because I don't want to write out light years the whole time. If it makes you happy to write out light years the whole time, go for it. And now the second piece of information I have is that this distance is equal to 9.461 times 10 to the 15 meters. So this unit right here automatically goes diagonally and down. And the problem tells me that 1 light year equals 9.461 times 10 to the 15 meters. Now you could stop here, find what that's equal to, and then convert your answer into megameters and picometers. But I'm going to run through this whole thing to just show you how you can keep it set in one equation to get to megameters. So automatically, before anything else, I know that this unit is transferring down here. And my target unit is megameters. So I'm going to go ahead and write that up here. And if I look at a SI prefixes table, I can see that mega, the prefix mega, equals 10 to the 6. And so that tells me if I have this m right here, and down here, instead of writing m, I replace it with what it represents, 10 to the 6. I have 10 to the 6 meters equals 1 megameter. And technically we should write it like this. So what this setup is really saying is 4.35 times 9.461 times 10 to the 15 over 1 times 1 over 1 times 10 to the 6. So for this first one, I'll spend a little more time showing how you might set this up in a calculator on a TI-30. If you have a TI-84, 83, it's similar. But I think people find it helpful just to know how to set up the calculator to begin with. So if I try to get this visible. Oh, well, let's play around with the light, see if I can get this working. Well, it's giving me a hard time, but hopefully you can at least see the buttons I'm pressing here, right? What you want to do first is hit the second button, and then go over here and put mode. And if you can see my screen, it has flow, psi, and Ing for science engineering. I want to set this up in science. And so by doing that, your answers will automatically come out in scientific notation. And you know what, this screen is not broadcasting my calculator, so what I'll do is post a separate video, so I don't take too long on this one, showing you guys how you would enter it into your calculator. So if I do this, 4.35 times 9.461 times 10 to the 15 divided by 1 times 10 to the 6, then I should get an answer of about 4.12 times 10 to the 10 megameters. I'm going to put my answer in a box so I know where to find it. And again, if you didn't get that answer, it was probably a calculator input issue, and so I will put up a separate video with the calculator so it's focused and has the right lighting for the calculator screen. Right, so for the second part, I'm going to do the same setup, just run through it for good practice. So the beginning of our table is going to look the same. Alrighty, and this time though, I'm going to go from meters to picometers. And picometers aren't worth the same thing. Picometers are worth 1 times 10 to the negative 12. So I'll put 1 times 10 to the negative 12 meters in 1 picometer. And I forgot to show this earlier. This lets the units cancel out, right? If we treat them like variables, anything divided by itself equals 1. And then that leaves us with just the target unit left, in this case, which is picometer. And so if we're paying attention, we should expect the first number to be the same, right? We're still going to have 4.12 times 10 to the something, but this time picometers are much smaller, so we should expect to have a lot more of them. And so it's 10 to the 28 picometers. And so that's how you would do the first one for parts A and B. For the second problem, it's a little bit easier actually because we don't have to do the first step. It's already giving us our units of joules, and so in that case we just have to scale it to kilojoules and nanojoules. And remember, they technically represent the same thing. It would be like telling someone your height in feet or in inches or in centimeters. Your height is still the same. It's just a different way of expressing it. So for number 2, A, I have that it is estimated that the sun will exhaust all of its energy in about 10 billion years. By that time, it will have radiated about 1.2 times 10 to the 44 joules of energy. Express this amount of energy in A kilojoules and B nanojoules. So I'm starting off with 1.2 times 10 to the 44 joules of energy. But this time I only need to do a second column because I don't have to convert from some more abstract unit like light years to meters. I already have joules. And so I'm looking at my table and I see that kilo is equal to 10 to the 3. So that tells me that 1 times 10 to the 3 joules equals 1 kilojoule. Right? So that's just saying there are 1,000 joules in a kilojoule. Right? So in this case, I just have to do 1.2 times 10 to the 44 divided by 1 times 10 to the 3, and that's going to give me 1.2 times 10 to the 41 kilojoules. And again, we can see that these units cancel to give us that. Now you might say, how did I spit that out so fast? I did not have the answer memorized, but there's a trick that'll let you do this without a calculator. So going forward now, I'm going to show you the trick. I think it'll save you time going forward. And if you need me to go through them in a more longer process, just let me know and I'm happy to do that. You can email me or message me on Google Classroom. So in this case, I have 1.2 times 10 to the 44 joules. Go ahead and transfer this unit down here. My target unit is nanojoules in this case. And so I need to figure out how many joules are in a nanojoule. So I'm looking at a metric conversion table, and I see that it's 1 times 10 to the 9, negative 9. And so in this case, I'm going to show you the shortcut. Since these exponents are factored out, it lets us use a trick. If you know anything about dividing and multiplying exponents, it's actually not that bad. So I'm going to say equals 1.2 times 10, like this. And in my parentheses, I'm going to put parentheses, I'm going to take this exponent minus this exponent, because when you're dividing exponents, it can just become a subtraction problem. So I have 44 minus negative 9, and that's going to give me 53. So 1.2 times 10 to the 53 nanojoules. Right, so you can see the shortcut does make things a little bit faster. So going to number 3. For number 3, it says the smallest living organism discovered so far is called a mycoplasm. Its mass is estimated as 1.0 times 10 to the negative 16 grams. Express the mass in petagrams, femtograms, and attograms. So first of all, what I have is 1.0 times 10 to the negative 16 grams. That's a really small number because it's a really small organism. And so for part A, it's asking me to put it in petagrams. I personally don't have that memorized, so I look at my table and I see that a petagram is 10 to the 15. So 1 times 10 to the 15 grams equals 1 petagram. Like that. And so I'm just going to use my trick again. 1.0 times 10 to the negative 16 minus 15. And again, it's minus because they're divided. I'll show you another example in a moment where they're not divided, they're next to each other, so the process is a little bit different. And hold on, I'm trying to make this .chem easier to read for you guys. Alrighty, so 1.0 times 10 to the negative 16 minus 15, and negative 16 minus 15 is going to be negative 31. So 1.0 times 10 to the negative 31, and it's petagrams. And you'll notice that a lot of the prefixes that represent large numbers end up being capital. Oh, we can't see that. Zoom out a little bit. There we go. So since peta represents 10 to the 15, that's a large exponent, we see it's a capital letter here. The capitalization matters. You can notice up here that a picometer, which is smaller, has a lowercase p. So make sure you're paying attention to that, and any table that you're looking at to get these prefixes will show you whether or not it's capitalized. Alrighty, for the next one, for B, I have the same start, 1.0 times 10 to the negative 16 grams. And in this case, I am converting to femtograms, and so if I look at my table to see what a femtogram is, it says femto means 10 to the negative 15. So 1 times 10 to the negative 15 femtograms, or my bad, grams, equals 1 femtogram. And so same process here, 1.0 times 10 to the negative 16, and then in this case, it's minus negative 15. And remember, when you're subtracting a negative, it's just an addition problem. And so negative 16 minus negative 15 gives me negative 1. So I have 1.0 times 10 to the negative 1 femtograms. And your calculator might have given you 0.1 for your answer to that, and 0.1 means the same thing. So if you got 0.1, you did it correctly. For C, it's the same process again. At this time, we're going for attograms. And attograms are worth 10 to the negative 18. So I have 1 times 10 to the negative 18 attograms, or, my gosh, I keep making the same mistake. That's why I use a pencil. Grams equals 1 attogram, right? Again, make sure that you don't do what I did. We want our units lined up here so that they cancel out, right? And then the same process one more time, 1.0. And I apologize, I'm left-handed, so I can't write without blocking the screen. But it is what it is. Negative 16 minus negative 18. And negative 16 minus negative 18 gives us 2. So our answer is 1.0 times 10 to the 2 attograms. And if your calculator spit out 100 for that, then that's the same thing as 100. So that means you also did the problem correctly. Alrighty, for number 4, this one, these prefixes you won't usually find on a metric conversion table, so as you can see, the problem gives it to you. And I have that the extreme prefixes that are officially recognized are yocto, which indicates a fraction equal to 10 to the negative 24, and yada, which indicates a factor equal to 10 to the 24. The maximum distance from the Earth to the Sun is 152,100,000 kilometers. Using scientific notation, express this distance in yoctometers and yottameters. All right, so we want all of our numbers in scientific notation. And if you have your calculator in science mode, you could punch in 152,100,000 and it would spit it out for you. And what you would get for that number is 1.52 or 1.521 times 10 to the 8 kilometers. And the reason I'm doing this again is if we factor out this exponent, that makes this trick possible, right? If we have the big number 152 million all written out, then we can't do the trick with the exponents, which does save us a lot of time. So I have, in this case, trying to convert it from kilometers to yoctometers. Now there is a way to go straight there, but for the sake of using the same method and not confusing anyone, I'm just going to go from kilometers to meters, and then I'm going to go from meters to yoctometers and yottameters. Right, so I know that 1 times 10 to the 3, okay, so this is probably a mistake that you guys made as well. And I've worked through this in front of 4 classes, and I still mess it up, but we can check ourselves. So I have that 1 times 10 to the 3 meters equals 1 kilometer. Right, now in this case, I have a value up here instead of just a 1, because if you ask yourself, well, are there 1,000 meters in a kilometer, or are there 1,000 kilometers in a meter? Hopefully, most of us realize that there are 1,000 meters in a kilometer. The meters are the smaller unit here. And then I'm just going to continue along, and in this case, I'm going from meters to yoctometers. Notice yocto is the smaller one, so it uses a lowercase y. And it tells me that it's 10 to the negative 24. So I have 1 times 10 to the negative 24 meters in 1 yottometer. And these units cancel out, so I know I have it set up the right way. And so in this case, I'm going to do the same trick, but we have 3 steps. So I have 1.521 times 10, and this time in the parentheses, I have 3 values to work with. So I have 8, and this time I'm doing a plus because this is up top, so these are being multiplied. So 8 plus 3, and then this one's still in the bottom, so it's minus negative 24. And that's going to give me 1.521 times 10 to the, what do we got, 11 plus 24, so to the 35 yottometers. Right. Now yoctometers are on the opposite extreme, and so we can set up our table the same way. I think for the sake of time, I'm just going to set it up with the exponents, but again, it would be the same process. It's just here, instead of saying 10 to the negative 24, it would be 10 to the positive 24. So if I set that up right down here for b, then I have 1.521 times 10 to the 8 plus 3, so that's my conversion to meters from kilometers, and in this case it's just going to be minus 24, so this is going to be a smaller number. So if I do 11 minus 24, what does that give me? Negative 13. So I have 1.521 times 10 to the negative 13 yottameters. And this time it's a capital Y because it's the larger of the two units that starts with a Y. Okay, I'm going to go ahead and cut it off here for the